Hey mathematicians, Justin here. Grab a hairnet and some hearing protection. You're joining me on the factory floor today. I'm getting a reputation as a bit of a math whiz around here, so my manager has a special task for me today. Measuring, then going to the hardware store and buying the right amount of paint to repaint all sides, top and bottom, of our storage tanks. Time to get to the math. At Circleville Candy Company, we store different liquid ingredients in large tanks. We have storage tanks of milk, cream, corn syrup, and more. These tanks are all cylindrical, meaning they're shaped like cylinders. Quick review, are cylinders a 2D or 3D shape? Cylinders are three-dimensional, or 3D. That means they're a solid shape that can be picked up. For any shape, though, we can calculate the amount of space on the inside and the amount of space around the outside. For example, this circle's circumference is 20 pi. That's the space around the outside. And the circle's area is 100 pi. That's the space on the inside. For a 2D shape like this circle, the amount inside is called the area, and the distance around the outside is called the perimeter. But for a 3D shape, the terms are different. The amount of space inside a 3D shape is called volume. Picture a water bottle. How much water it can hold is its volume. The exterior measurement for 3D shapes is the area of each face added together. We call it the surface area. For example, the amount of wrapping paper it would take to cover the bottle is the surface area. But back to my job. How much paint will I need to repaint all the sides, top and bottom, of the cylindrical storage tanks? What measurement will I need? Area, perimeter, volume, or surface area? Write down your answer and your reasoning. Since cylinders are 3D and the paint will cover the outside, I'll calculate the surface area of each cylindrical storage tank. Let's take a closer look at what a cylinder actually looks like. The middle part is curved all the way around. Cylinders can be open, like paper towel tubes, or closed, like a water bottle. In either case, the top and bottom of the cylinder are flat, circular faces. If we break apart the cylinder by cutting it up the side, it unrolls to lay flat like a rectangle. So to draw the net of a cylinder, we draw a rectangle for the center portion and two attached circles for the top and bottom faces. Take a moment now to practice drawing the net of a cylinder in your notes. Your net should contain two circles and one rectangle. How can we calculate the surface area of a cylinder using this fact? Write down one idea in your notes. What if we calculated the area of the two circles and added that to the area of the rectangle? That would give us the total surface area, the area of the sides, top, and bottom of the cylinder. The circle area formula is A equals pi r squared. There are two circles, so that's 2 pi r squared. What else do we need to add? Yeah, add the area of the rectangle, which is found by multiplying the base times the height, or A equals BH. Take a look at this animation, paying close attention to the top edge of the rectangle. There, did you see it? Watch it one more time. The center part of the rectangle unfolds, the top and bottom circular faces lift up and away, and the base of the rectangle is the same distance as the circumference of the top circle. So instead of using base in the rectangle's area formula, we can use the circle's circumference. What's the formula for the circumference of a circle? Yes, C equals 2 pi r. Let's replace base with the circumference, 2 pi r. The height of a rectangle is the same as the cylinder's height. So to find the area of the rectangle, we can use the formula 2 pi r times h. So, in total, the formula for the surface area of a cylinder is A equals 2 pi r squared plus 2 pi r h. Let's practice this formula with our first cylinder. Each cylindrical milk storage tank has a height of 10 feet and a radius of 5 feet. What's the surface area of one tank in terms of numeric square feet? We start with our formula, A equals 2 pi r squared plus 2 pi r h. Next, underline the r and circle the h. Right, r is 5 and h is 10. Substitute those into your equation, then check back in. You should have A equals 2 pi times 5 squared plus 2 pi times 5 times 10. Since we want our answer in numeric square feet, though, we better substitute 3.14 for pi. So it's now A equals 2 times 3.14 times 5 squared plus 2 times 3.14 times 5 times 10. You finish it from here and write your own final answer. All right, we follow gems to solve. We don't have grouping symbols, but we do have an exponent. 5 squared is 25, so now it's A equals 2 times 3.14 times 25, plus 2 times 3.14 times 5 times 10. Next up is multiplication, going from left to right. The first term is 157. Then we multiply 2 times 3.14 times 5 times 10 to get 314. 157 plus 314 is 471 feet squared. That's the surface area of each milk storage tank. Here's example 2 with the cream storage tanks. They're shaped like cylinders with a radius of 9 feet and a height of 3 feet. What's the surface area of one of the cream storage tanks in pi units squared? For this one, I want you to underline the r and circle the h in the problem, write out the formula for the surface area of a cylinder, and substitute your values for r and h. Then, unpause and see how you did. You should have underlined 9 and circled 3. The formula is A equals 2 pi r squared plus 2 pi r h. With substitutions, it's now A equals 2 pi times 9 squared plus 2 pi times 9 times 3. Notice that we aren't substituting 3.14 in place of pi this time. That's because we want our answer in terms of pi square units. We use gems to solve, so start with the exponent. Now, it's A equals 2 pi times 81 plus 2 pi times 9 times 3. Next up is multiplication, working left to right. In our first term, 2 times 81 becomes 162. So now it's 162 pi plus 2 pi times 9 times 3. 2 times 9 times 3 is 54. So we get 162 pi plus 54 pi. We'll add the coefficients, and our final answer is 216 pi square feet. For example 3, solve it 2 ways. Once getting the answer in pi square feet, and once in terms of numeric square feet. The corn syrup storage tanks are cylindrical with a height of 6 feet and a radius of 2 feet. What is the surface area of one corn syrup storage tank? You got this. Nice job, mathematicians. In terms of pi, the final answer is 32 pi square feet. And the equivalent answer in numeric square feet is 100.48 square feet. Pause to compare your work to mine. Now that I know the surface areas of the different tanks, I'm ready to head to the hardware store. There'll be more math once I get there and see how many square feet a bucket of paint covers. If you want to help me figure that out, there's a bonus problem at the end of the guided notes. In the meantime, finish the notes and practice levels 1 through 3. Until next time, keep questioning, keep calculating, and remember, the surface area is the total space on the outside of a 3D shape. See you next time!
Hey!